Objective, two-step equations. This is a review from 7th grade solving equations for two steps. The two steps to two-step equations. Step 1, use the addition or the subtraction property of equality to get the term with the variable alone and on the other and one side of the equation. Step 2, use the multiplication or division property of equality to get the variable with the coefficient of a 1. Remember that a coefficient is a number that's sitting to the left of that variable. There is, of course, one exception to the steps, and that's going to be example 4 when we get to that example. Vic number 1, remember, you want the variable positive and by itself on one side of the equal sign. Examples. 2x plus 10 equals 16. Now here we need to, so the first step said that we either are going to add or subtract. So since I have addition, then I must subtract. So this is what's being added, so 10 is what I am subtracting. So the first step here is I'm subtracting 10 from both sides. And this is the equality part of that property, okay? And the reason why is that, remember, this is an equation, so what we do to one side, we must do to the other side at all times to keep that balance. So when I subtract 10, 2x comes down, because we didn't do anything to 2x yet. Positive 10 and negative 10, they add up to 0. Those are additive inverses. And then 16 minus 10 is positive 6. So when I simplify this piece, it just goes to 0. Positive 10 and negative 10, we want that. That goes to 0. So now all I have left is a 2x. So that comes over. 2x equals 6. So at that step, either I'm multiplying something or I'm dividing something. And here, I have multiplication. 2 is being multiplied with x. So I must divide by that coefficient. And remember, the coefficient piece is positive 2. So I must divide by 2 on both sides. 6 divided by 2 is 3. And 2 divided by 2, remember that is where we get that positive 1 coefficient is what we want. So x equals 3. If I check that and I plug positive 3 in to where my x is, okay, 2 times 3 is 6. 6 plus 10 equals 16 when I simplify all the way down. And 16 equals 16, that is a true statement. So I know that 3 is a solution for that equation. Example number 2. Negative 18 minus 3y equals 12. So what is being added or subtracted here? Well, here's the term with the variable, but this is what's being subtracted, knowing it is negative. So if it's negative, that tells me I know there's subtraction going on. So the additive inverse of that is a positive 18. So notice that when I have a positive 18 here, I must do the same to both sides. So negative 18 plus 18, both of those add up to 0. Okay? So negative 3y is what comes down. So when I simplify this, when I push these together, that gives me negative 3y equals 30. And at this point again, here is my coefficient. So that is what I must divide by at this step. So negative 3 divided by negative 3 gives me that positive 1 coefficient. And that is what we want. That's why the process works every single time. So 30 divided by negative 3 is negative 10. So y equals negative 10. And again, I can check myself. Plug in negative 10 in for y. I get negative 18 minus 3 times negative 10 equals 12. Well, when I simplify here, that is actually a negative 3 that I have to distribute through multiplication with the negative 10. So that's actually a positive 30. So when I simplify that side, I do get 12 equals 12. So I know that negative 10 is a solution for this equation. Example number 3. Now here, my coefficient is negative 1/2. So the variable is actually broken up as like a fraction. Okay? But again, I'm going to approach it the same way. So when I see this, I have a positive 4, so I have 4 that's being added here. So I know I must subtract. Addition and subtraction, those are inverse operations. So what I do to one side, I must do to the other. So as I bring my information down, remember, -4, +4, those add up to 0. That's what I get. So m, -1/2 of m is here, is brought down, and -14. So when I simplify that, I get m over -2 equals -14. This stage is this is where division looks like. So when I have that fraction bar, I know my coefficient, I have a division piece. So well, what is being divided here? Well, -2 is what's being divided. So the additive inverse of division is multiplication. And we always multiply or divide by that coefficient. So since we're multiplying, my coefficient is that, so we are multiplying by the reciprocal. So the reciprocal of -1/2 is -2. Remember, reciprocal, flipping, right? So when I flip that, it does become -2. And that is what I have here. So I'm multiplying both sides by -2 because that's what I'm dividing by. So m equals 28. So when I plug in the solution here, 28 for m, which is right here, and I divide that by -2, I get -14. Plus 4 equals -10. When I simplify those two together, I do get -10 equals -10. All right, number 4. This is the one that's the exception to the rule. Now here, this whole left side, x minus 4 divided by -3, this whole left side is a fraction. So division, nothing's being added or subtracted first. Remember, order of operations, multiplication, division are above addition and subtraction. So here, I must get rid of that fraction first. So if I have division, I need to multiply. So what's being divided? -3 is being divided. So that is what I am multiplying both sides. Just like I did up here when I got to this step, okay? That's what I had a fraction. So same thing applies. So I must divide by that. So notice when I divide -3 and then -3, that brings my numerator down because the fraction goes away. This will work every single time. So again though, if I am multiplying by -3, I must multiply by -3 on the right hand side, which -6 times -3 is a positive 18. And so x minus 4 comes straight down. And so this is where now I'm going to add or subtract to get my variable alone. So I have a subtraction, so I must add both sides by 4 to keep the equality true. So that gives me x equals 22 when I add 18 plus 4. And again, I can check that when I plug in 22 in for my variable. So 22 minus 4 is positive 18. Now I'm ready to divide by -3. And -6 does equal -6. So let's do some practice. Example number 1. X over 5 plus 9 equals 11. So I'm going to go ahead and we are going to draw, I call it the river, so we're going to draw the river. And we're going to specify exactly where our equal sign is, so because I need to make sure I have the same thing on both sides of the river. Okay? So here, I have a fraction, however, it's not the entire side like example number 4 was. So I have addition, so that means I must subtract 9 from both sides. By subtracting 9 from both sides, positive 9 and negative 9 go to 0, and x divided by 5 is what comes down on the left-hand side, equals positive 2. 11 minus 9 is positive 2. Now that step is where we have 5 is being divided. So the inverse operation of division, we need to multiply by 5 on both sides. So notice I'm doing the same thing on both sides. So this goes to a positive 1x, and 2 times 5, 2 times 5 is positive 10. All right, again, on example number 2, let's draw the river. And I have negative y, that's a negative 1y. All right, so make sure you know that there's a understood 1 sitting there, but it's negative. So negative 1y minus 5 equals 11. So what am I adding or subtracting here? Well, I'm subtracting 5. So to get rid of the negative 5, I need to add 5. Okay? So remember, once I'm ready to add 5 to both sides, negative 5 and positive 5 add up to 0. Negative 1y comes down, and 11 plus 5 is 16. Okay? Now remember, this is the piece where we have multiplication, so the coefficient is negative 1. That is what I must divide by on both sides, by negative 1. Because notice here, I have negative 1 divided by negative 1. That gives me my positive 1y. That is what I need. And on the right-hand side, that gives me a negative 16. So y equals negative 16. Example number 3. 18 minus n equals 21. Let me go ahead, identify the river, the equal sign, and let's go ahead and begin the process. Now here, I have 18 minus n. Here's my variable, but this is the term that I need to get rid of, the one that doesn't have the variable with it yet. All right, so 18 is positive, so I know I need to subtract. That's the additive inverse, a negative 18. So I must subtract 18 on both sides. Okay, by doing that, that gives me positive 18, negative 18 gives me 0. Negative n comes straight down. Okay, and then 21 minus 18 is positive 3. This is the one where, remember, there's a negative 1n sitting there. So what's my coefficient? Negative 1 is my coefficient. Since I have multiplication, I must divide by my coefficient of negative 1. And then by doing that, negative 1 divided by negative 1 gives me that positive 1n. 3 divided by negative 1 is negative 3. Okay. Example number 4. There's my river. What is being added or subtracted? Well, 4 is being added, so that means I must subtract. Sorry. And so here's my additive inverses. I know I'm good, because now I know that's going to add up to 0. So the term that has the variable is going to come straight down. And then 16 minus 4 gives me a positive 12. All right. Now, again, what's being divided? 8 is being divided. Remember, there's an understood 1. So my coefficient here is 1/8. What's the reciprocal of that? 8 is the reciprocal. So notice that when I say multiply by 8, I'm actually multiplying by the reciprocal. So multiply 8 here, multiply by 8 here. So that simplifies to positive 1m, and 12 times 8 is 96. Okay. Last example for practice. There's the river. Okay. 10 equals 2n plus 1. Notice that a positive 1 here. This is the term of the variable. So the constant that's sitting here is a positive 1. So the additive inverse of that, I need to subtract. So negative 1 is on both sides of the river. That adds up to 0. This term, 2n, goes down. And then 9 is on the left-hand side. So here I have multiplication. 2 is my coefficient. So with my multiplication, division is what undoes that. And you always divide by your coefficient, always. 2 divided by 2 gives you that 1, positive 1n, and then my answer is 9/2. That's already simplified, and I'm going to leave it as a simplified fraction, improper fraction. Okay? All right, last problem. Is an application problem. Suppose you are helping prepare a large meal. You can peel 2 carrots per minute. You need 60 carrots. How long will it take you to finish if you have already peeled 18? So we've already done 18. So the very first thing we need to do is to define a variable first. So let's define. We're going to use x. Okay. X is going to represent our minutes, because we're asking the question, how long? So that's how I know we're talking about, time. So we're going to use it for time, but we're going to specify that it's going to take minutes. All right? Okay. Go ahead and let you know that would be time right there. So now I know I have already done 2 carats per minute. And remember, per, I know means multiply. So 2 carats per minute. I need 60 carats. And I have already peeled 18 carats. Okay, so I've already done 18, and 60 is the total that I need. All right, we're going ahead and identify the river. So I'm taking what I have already peeled, and I'm going to subtract it from how much the total that I already that I need. So 18 is what I've already done. I need 60, so it makes sense that I'm going to subtract from both sides of 18. So 2x comes down, and that's 42. So 18 from 60 is 42. Now here is where 2 is my coefficient. That is being multiplied. We always divide by that coefficient, and x is on the left, and then 21, x equals 21 on the right. So what does that mean? That means it's going to take her 21 minutes to peel, as far as to finish. It's going to take her 21 minutes to finish peeling.